In this next case, use Simpson's rule with 6 intervals to determine the value of the integral from 1 to 1.6 of ln of x dx, correct to 3 decimal places. So before you start using the rule, you must know, have you been told the intervals or strips or ordinates? So in Simpson's rule, each and every strip has its own interval, isn't it? Meaning when they talk of 6 intervals, they are talking about 6 parts or 6 strips, isn't it? And those strips are what we are interested in. Have you seen that? If they say the 6 ordinates, it is ordinates minus 1 to give you the number of strips. 6 ordinates means 5 strips, isn't it? So number of intervals will be the same as the number of strips. Are we together? So when you are told 6 intervals, what does that imply? 6 intervals imply 6 strips or parts, isn't it? So it means we are going to divide it into 6 equal parts. So if the interval is starting from 1 and ending at 1.6, meaning it is starting at 1 and it is moving up to 1.6, what is the whole of this interval? So it is 1.6 minus 1. So you get the whole of this length here. From here, okay, is 1.6 minus 1, which is 0. And this 0.6, we've been told to divide it into how many equal parts? 6 equal intervals, or 6 strips, isn't it? So what is the edge? What is the height of each and every interval? It is the whole of this interval, which is 0.6 divided into 6 equal parts to give you the edge, the interval of each and every part, isn't it? 0.6 is for all of them. So what will be the interval of one part? Senior, we have 6 parts or 6 intervals. So one interval will have what length? 0.6 divided by 6 parts, isn't it? So a length of 0.6, if we divide it into 6 equal intervals, we get 0. So we found our edge is 0.1. And we are starting from 1. After getting our edge, the next thing we get is the function. Y is a function of x, isn't it? So we have y is a function of x. What does that imply? When you are getting the area in integration, area you are integrating f of x dx, isn't it? Meaning the whole of this, which is here f of x dx, y being a function of x, meaning that f of x is y. See there? So you are integrating y d, meaning what is here is what? Is y. See there? Yes, because for you to get the area is supposed to be you integrate f of x dx from the given interval a to b. But y is a function of x, meaning where there is f of x you put y, isn't it? So where there is f of x, if I put y, I get the area is integral from a to b of y dx. But here I have ln of x dx, meaning this ln of x is y. Are you seeing that? Are we together? So that is what is important. What is important is to know edge, which we found to be 0.1. The whole interval, 1.6 minus 1. You get 0.6. And that 0.6 you divide into 6 equal intervals, isn't it? So 0.6, if you divide into 6 equal intervals, each interval will take what? Will take 0.1. So you get h. After getting h, you get y, which is a function of x. And that function of x is what? ln of x. Are we together? After that, you form a table to get the y values. Before forming a table, you write the formula. What is the formula in Simpson's rule? 6 intervals, meaning you are going to reach y6. This is 6 y6, isn't it? Not y6 in this case, y? Intervals is the same as the number of strips, isn't it? So when we have 6 intervals, it's going to be y6. Yes, 6 intervals means, what I'm trying to explain is the 6 intervals means how many ordinates? 7 ordinates, very good. So 7 ordinates from y0 to y6, isn't it? So I'm going to have a table with how many parts? 7 ordinates, with 7 ordinates, because the table is dealing with ordinates, isn't it? But the parts are dealing with strips. So 6 intervals imply 7 ordinates from y0 to y6, isn't it? So can you form that table? Form the table. That is the title. Then you put 7 parts. 1, 2, 3, 4, You don't even need that title. I don't see the need of that. 6. There's no need of that, isn't it? 7 parts, we just divide it into 2 parts. Then before you start keying your values, you must note what you've been told. What have you been told? Correct to 3 decimal places, isn't it? So this 7 part, the first part starts from here, from X note, meaning this one is the X6, 6 intervals. X6 is the last one, isn't it? The first one is X. Are we together? Yes, so 6 intervals implies 6 strips, and 6 strips in Simpson's rule implies 7 ordinates, isn't it? So 7 ordinates start from X note to X6, okay? So what is X note? X note you will always be given the start of the interval. X note is 1. So for you to get X1, it is X note plus H. Simple. So X note plus H you get 1.1. Then X2, X1 plus H you get X2. X1 plus H, what do you get? X note plus H gives you X1, isn't it? X1 plus H gives you X2. So X1 plus H you get? Then X3. X2 plus H gives you X3, isn't it? X2 plus H, 1 point. Then X3 plus H gives you X4, isn't it? Because H is the interval. Silio. You get 1 point? What is X5? X4 plus H gives you X5, which is 1.5. Then what is X6? X5 plus that you get? So, you don't even need to know that you are going to X7. Once you reach the highest interval, you stop there. So knowing the number of ordinates is not important to us. Are you seeing that? Once you've seen the highest interval, which is 1.6, you reach 1.6, meaning that is the last ordinate. So knowing it is not important. It will come out by itself. Are you seeing that? It will come out by itself, because you see it is the upper ordinate which is on top there, the last one. Are we together? Good. So that is that. It will always come out, whether it was mid-ordinate rule. When it was mid-ordinate rule, meaning the value of H for mid-ordinate rule will be different from this, isn't it? So mid-ordinate rules, when there are 6 intervals, it will imply 6 ordinates. So mid-ordinate rule will reach X5. Will reach as X5. Okay? And for it to reach X5, it means when you have 6 intervals in mid-ordinate rule, it is still going to be the same as 6. 6 strips. Yes. So it means for mid-ordinate rule, it is even more simpler. You reach this at 5. Because it is in the middle, it is not in the end. What is in this end is not in the mid-ordinate rule. We are dealing with the one in the middle. And they are not this, it is going to be a different scenario. By the way, I need a case of mid-ordinate rule is very different from this, okay? So when you have X naught, I now want Y naught. Remember, Y is ln of X. So if this is Y naught, this is X naught. Are you seeing that? So Y naught, you go to the calculator, ln of X naught. And I hope you place the calculator, you fix it to 3 decimal places, isn't it? So for you to get Y naught ln of X naught, meaning ln of 1, you get Y naught to be? So you press in the calculator ln of X naught? Or ln of answer, where there is X naught, you put answer, isn't it? So Y naught, Y is ln of X, it means Y is ln of answer because X is our answer, isn't it? So when our answer is 1 is equals to 1, then you go ln of answer. What do you get? 0. Then you press AC to minimize, isn't it? Then you put 1.1 is equals to that, then you replay back, see there. So what is Y1? So here is X1 will give us Y1. So Y1 will be ln of X1. So ln of 1.1, isn't it? You get it to be 0.095, isn't it? Then here, if here is Y2, then this is X2. So it means Y2 is ln of X2. Are we together? So ln of 1.2, ln of X2, X2 is 1.2. ln of 1.2 is 0.1. 3?
H2.
Or 0.182. Then you move to the next one, y3. If here is y3, meaning that is x3, ln of x3, isn't it? So ln of 1.3, x3 is 1.3, ln of 1.3, 0.2, 26, 2. Then y4 will be ln of x4, which is 0.3, 6, isn't it? Then you move, x5 will give you y5. y5 is ln of x5, ln of 1.5. Okay? 0.4? 0.405. Then move to y6. 0.470. Good. So you found all of them, isn't it? So what is the area in Simpson's rule? So you know, you come and list your y's. You list your y. We have y0, y1, y2, y3, y4, y5. y5 is the last. y6. y6, isn't it? So the area in Simpson's rule is a third edge, isn't it?
Yes.
Then the first sum of the first and the last, isn't it? So if you look at what you listed, the first and the last is y0 and y. Simple. y0 plus y6. Then twice the evens. The evens, which evens are left? y2 and y. Are we together? So twice the evens, y2 and y2, the evens which are left. So you can see 2 times 2 is 4. The other one also, if you multiply that, you get 4, isn't it? Then 4 times the odds. Which odds are left? y1, y3 and y? y1, y3 and y? y5. So y1 plus y3 plus y5. So at the end, you get everything. So what is the area? A third edge into y0 plus y6, the last, then twice the evens which are left. y2 and y4, then 4 times the odds which are left. Like that. So what do we have? If you multiply 2 by 2, you get 4, 4 by 1, you get 4. You can see how that is balancing if you start from y0. Just a methodology, activity of mastering, okay? So what do you get here? Start with what is inside the bracket is what you record. Start with what is inside. So I have, area is a third times edge. What is edge? 0 point? A third times 0.1. Then open the bigger bracket. So start. Deal with this smaller bracket. y0 plus y6. Go. 0 plus 0.470. What do you get? I'm done with this smaller bracket, isn't it? Then move to this smaller bracket. 2 into y2 plus y4. y2 is this plus y4 is this. Then you multiply by 2. What do you get with all of this? What do you have? y2 plus y4. y2 plus y4. Then you multiply by 2 after adding them. Or 2 in bracket, that plus that, isn't it? What do you have? 1 point? 1.036. I'm done with this. Then this other one, go to the computer and deal with this smaller bracket. 4 into y1 plus y3 plus y5. 4 into y1 plus y3 plus y5. What do you get with the whole of that part? 3.0? 3.048. Are we together? So can you now work the whole of that in the calculator? A third times edge in bracket this plus this plus this. What do you get with the whole value? 0.152. So that is the approximated area by Simpson's rule. Now, we want to use this same example with mid ordinate. This same example. Are you seeing? Are we together? This same example. So use mid ordinate rule. Use mid ordinate rule. Let us use that same example with mean ordinate rule.